Greetings, I'm Dave Truss, and I'm here with Joe Truss, and we are doing sort of a response video to Nassim Haramein, but also we're going a little bit in depth about our ideas around the fact that we live in a tetraverse, and that the foundational shape of that structure is the cube octahedron. Nassim Haramein comes from a different approach, and I'll let Joe talk a little bit about that before we watch his video.
Okay. So what we're looking at is Nassim Haramein has arrived at something that he calls 64 tetrahedral. Now, he's using the geometry, but he is a mathematician and a cosmologist. And what he has done is he has associated this 64 tetrahedral structure as being the central grid out of which the universe is formed. He's starting already from compounds, and what we would like to do is to show an alternative way of arriving pretty much at the same graphic diagram that he has, but arriving at a place that starts from the elemental, which is the Planck distance. If we start working from the Planck distance, which is the absolute unit one other than zero, and we build it outwards, we're building a different kind of logical structure, but we're arriving at exactly the same geometric form that Nassim is forming. So what we want to do is we want to start with a short video by Nassim where he's talking about the 64 tetrahedra and the significance to him, and then we will turn and show you some alternative ways of not just looking at how that is built, but looking at the meaning cosmologically of what that would mean in a frame of cosmology, as an example. Let's start with the Haramein video.
The 64 tetrahedron grid kind of bloomed in to a whole new understanding of the structure of the vacuum. It was exactly what I needed. It had an equilibrium at the center that was actually surrounded by another equilibrium.
And I want to pause there to say his equilibrium that he's talking about is the cube octahedron. The cube octahedron is considered equilibrium because the radial length is the same as the edge length. And I think that's really important. And that is the starting point for both of the geometries, the ones he discussed and the ones we discuss. We'll continue the video.
That's right. The term that Buckminster Fuller used is vector equilibrium, which means all of the vectors of those energies, radially and edge, are exactly equal. And there's only one geometric form in the universe that does that, and it is the cube octahedron.
Great. Let's continue.
And you could visualize this structure growing in perfect fractal octaves from infinitely big to infinitely small. I had not only my polarities producing the equilibrium and singularity, but as it did, it produced fractal structures that could be scaled from infinitely big to infinitely small. I felt I had found something very profound. It was a true three-dimensional fractal structure, and it grew in perfect octaves. I could see that this metric could actually be built in a completely different way as well. It could be built out of 8 star tetrahedron, each made out of 8 tetrahedron each. The 8 star tetrahedron coming together produce the 64 tetrahedron grid. 8 star tetrahedron are built by 8 tetrahedron, have their tetrahedron pointing out, radiating out. And when they come together, they produce the vector equilibrium in the middle, which is 8 tetrahedron pointing in. So I had now both of the side of the event horizon that produced the boundary condition, the radiative side and the contractive side of the event horizon. I thought, this is it. I found it. And I got very, very excited. I thought, this has all of the elements necessary for me to be able to map out and describe the structure of the vacuum. The key to the knowledge necessary to understand creation.
Okay. Now, his tetrahedron. What do you call it? 8?
Star tetrahedron, which are intersecting two frequency tetrahedron in our language.
And okay, so let's look at how he constructs that right now. And let me just spotlight. Here we go.
Lovely.
So he's building what's called a 2-frequency tetrahedron. This is a 1-frequency tetrahedron, meaning there's one edge length. And he's building a 2-frequency tetrahedron. To do that, it's 8 times the volume, because what you're doing is you're creating a second layer here. And so as I add this on, what we see is it now has 1, 2 frequencies. The interesting thing about this shape is it's a triangle, 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 and inside the center is actually an octahedron. And so I just wanted to mention that. But when he talks about what he does is he has intersecting 2-frequency tetrahedron,
which he calls the star tetrahedron because of the 8. You've created 8 of those triangular.
Yes. And so then there's a star, the star tetrahedron that he starts with.
Lovely.
Right? And so if you look, there's a red tetrahedron. You can see the red tetrahedron and a green tetrahedron intersecting. So that's the base shape that he works from. What we say is that vector equilibrium he talks about, that cube octahedron, starts here with the cube octahedron and comes with the shapes coming out of the triangular sides. And we'll talk about that in a little bit. But we just wanted to show the difference between our starting point and Nassim's starting point, which both use the same geometry. All right. So let's go on to your presentation now. And you can take control. Go full presentation. Yeah.
Okay. So what we have here, if we start with a more primitive starting point, which is, if we're looking at the quantum realm, what we're looking at is this thing called the Planck distance. The Planck distance is the smallest measurable distance that could make any sense in terms of mathematics, right? So the Planck distance itself is a number that defines the closest distance between objects in the quantum universe. So let's say we just have this thing called a Planck distance, and we call that an edge. And we put a bunch of these edges together into a box and we shake it for 13 billion years. Many, many forms are going to come out. But 2 forms that have to come out is you're going to get tetrahedron, which are 4 triangular faces that are just going to come together, or you're going to have a cube, which are 6 square faces that come together.
And
So let's start.
octahedron as well. Octahedron would come up as well.
The octahedron comes out of the formation of the collapsing cube. So let's start with an assumption. Let's say that the cube represents the Planck distance, which means that the edge length of a cube, the distance between any of the 2 vertices or nodes, is the Planck distance, which is shown in this diagram by this white line. We assume that's the Planck distance, and we build a cube using that distance as an edge. Well, when we build a cube, as Dave will show in a minute, the cube is floppy. The cube is not rigid. A tetrahedron is rigid. Once you construct those 4 triangles together, you cannot compress it any further. It's rigid. But the cube, if I just apply any pressure or even under its own weight in gravity, the cube will begin to distort and collapse. Now, as the cube collapses, something is happening. The 2 opposite vertexes of the square are going to fall closer together, but they're going to get stopped by the Planck distance. These 2 vertexes cannot get any closer than the Planck distance without violating the very essential pretext that we set up. So what happens to the cube?
Literally violating the Planck when you're saying the Planck is the smallest object.
Exactly. You cannot have anything smaller than the Planck object, and therefore this thing cannot collapse any closer than that Planck distance, which happens to be the same as an edge length. That's what we established in the beginning. So now all of the 6 faces of the cube will collapse down to where this becomes equivalent to an edge length. So you get a triangular diamond forming out of a square diamond. And in doing so, essentially, each face of this primitive cube will collapse down onto a Planck edge length. And what you find when you construct this, as Dave will do in a minute, is you have a form here that is a tetrahedron connected to an octahedron, connected to a tetrahedron that's turned 90 degrees from the bottom one. So tetra, octa, tetra, TOT. So we call this a tetra, octa, tetra. And so every cube that forms at the quantum realm will eventually become a tetra, octa, tetra. And this becomes the component building block of our form of the 64 tetrahedral.
I'm just realizing as we speak that we're talking about an octahedron, and we haven't actually constructed one to say this is what it looks like. So I'm just doing that very, very quickly. It takes just a few seconds here. So what you have here is a square right there with a pyramid at the top and a pyramid at the bottom. And so that is an octahedron and one of the central shapes. So looking first at the octahedron, what you see here, you can see the square shape, and it just has a pyramid on top of a pyramid.
And that sits in the center of the star tetrahedron that you built.
Yes.
Right?
And so that's the piece right there that you want to be able to see. When we talk about tetrahedron, we're talking about just a triangular shape, a triangular pyramid with 4 sides, the base and 3 sides. But when you look at this, this is a 4-sided pyramid, okay? And that is an octahedron. What we're going to go back to now is this cube and that idea of a floppy cube. And you can see structurally a cube doesn't want to hold its size. Now, as Joe said, what can happen is this can start to collapse. But when it collapses, it can't collapse more than this distance right here, because that is the Planck length. And so as that collapses to that distance, we'll put one on the other side as well. What ends up forming is each of the square sides collapses. And when that happens, you get this shape here. Now, if I hide the 2 triangles on the end, what you end up seeing is that same octahedron in the center. And so what this shape is tetrahedron, octahedron, tetrahedron. And that's what we call tetra, octa, tetra. We also call this one ray. And we're going to talk about rays in a moment. But now that we've constructed that and you can see the shape of the tetra, octa, tetra, I'm going to go back to Joe and his presentation.
So Dave just built this structure that we talked about, which is limited by this thing called the Planck distance. So what we've established is that the smallest possible structure in the quantum realm is going to be a tetrahedron. And because of the collapsing cube, it's going to be a tetra, octa, tetra connected. Now, remember we started with the cube octahedron. And the cube octahedron has 8 triangular faces and 6 square faces. So if I extend that figure, every one of these is a tetra, octa, tetra. And if I extend this tetra, octa, tetra from each of the 8 triangular faces, I get this intersecting star tetrahedron. But in this case, it is a 4 frequency, not a 2 frequency as Nassim Haramein has used.
Okay, I'm going to stop you there for a second. And what we'll do is, you talked about extending the rays out. And I think we need to jump back to this shape here. The central thing in Nassim's video, right?
Yes.
Vector equilibrium. And what you talked about was the idea that okay, for this shape, there's actually 8 triangles and 6 squares, right? And so let me highlight this just for a moment. Right? So 8 triangles and 6 squares. When you talk about these rays going out, if this is the central shape, what we have is, remember this tetra, octa, tetra? Well, I'm going to take one of the tetras off here, right? And I'm not going to stick it together because it's not going to work with the way that we have it. But what you're talking about is out of every one of these triangles, every one of them, what you're going to have is the first tetra. The tetra is, you can see this triangle with the red going down. That is the first tetra. And then comes the octahedron, tetrahedron on top, right? So tetra, octa, tetra. Now I have double the amount of magnets here, so it won't work easily. But I just wanted to start with that premise because it's important to understand that when you're talking about the rays going out, if this is the central shape, you have in every 8 different directions, you have tetra, octa, tetra expanding out. So let's go back to your presentation now because I think that'll help make a little more sense of what you're talking about.
Right. So here we are. So this is the form that Dave was just talking about. The inside of this form is the cube octahedron that he started with. And this would be the top triangle of that cube octahedron. And on every one of those triangles is an octahedron with a tetrahedron on top. So tetra, octa, tetra. Every one of these rays, R-A-Y-S is what we call them because they are radiative, moving outwards, is made out of tetra, octa, tetra. So the 8 triangular faces of the cube octahedron gives you the form. And this is why it fractally radiates outwards, as Nassim mentions. But this is the basic form. Now, as he has shown, you can make this out of different configurations, like intersecting tetrahedra, but we want to take it back down to the Planck constant. We're going to show that once you've established a Planck tetrahedron, you can no longer subdivide this piece. Everything in nature is made out of these components, tetra, octa, tetra. And a remarkable thing is that if I keep expanding this figure, there is no 3-dimensional object that exists in the universe that cannot be represented or made using this structure. So we want to make that point. Number one, it's a quantum structure. So once you establish that unit 1 of the tetrahedral edge, you cannot now come in and say, what is a half a tetrahedron? I can take 2 tetrahedra and say half of that is 1, but you cannot subdivide any of the quantum objects.
We'll be creating some videos around, is math invented or is math discovered? And I think the central piece is when you come to the doubling and dividing by 2, that's discovered. But when you're taking a single 1 unit and then dividing it, now you're going into invented math.
That's right, because every one of those units, if you can subdivide it infinitesimally small, you end up with infinities between 0 and 1. And our universe, we claim, is not infinite. We live in a 3-dimensional structured geometrical universe. So another way to look at that form is like this. I built this as well, which is really what Dave started to build. On the inside of this is a cube octahedron, triangle, square, and on top of every triangular face, which is the tetrahedron pointing down to the center of the cube octahedron, is a tetra, octa, tetra. And so you see that this blue top and bottom are axes. What we call the tetraverse is that there are 4 axes in a tetraverse, not just 3 as in X, Y, Z. And so here's your yellow axis, a blue axis, the green axis goes through the screen, and the red axis. But they're all basically tetra, octas, tetras, and they're connected by the structure of the cube octahedron on the inside. This form now is completely fractal, just as Nassim is saying, which means that as I expand this form, it will continue to radiate outwards omnidirectionally without any distortion. And the only way this can happen is because you have these 8 radiative triangular faces and the 6 contracting square faces, which is essentially XYZ against the 4 axes of the tetraverse.
Okay, let's pause there quickly because that's a big jump for people to understand. And I just want to jump quickly to this. And when you talk about the square faces becoming the XYZ, I'm going to switch this now and I'm going to put it down on a square face. So now you can see the base is square. And so if you look at this right now, you've got square going a square down to a square this way.
Yes, an axis in the center of the
A
square.
square going this way,
Yeah,
a square going this way. You basically have 3 right angle perpendicular
axis.
intersection. And so that would be the XYZ, right? And so to put it, if you look at it this way, front and back, up and down, left and right.
Right.
Okay. And so that's where the XYZ comes in. But when you're looking at XYZ and you expand out using XYZ, you get less and less stable. When you expand through the tetrahedral in 8 directions, that structure continually expands. I forget the term that Nassim Haramein talks about, octaves. And so the doubling and doubling maintains that structure, which is really, really important. So let's jump back to your image now, because I think that it makes a little more sense for people to understand when you say the square faces are the XYZ. I think that becomes something that a little easier to see.
That's right. And so this figure again shows these are the 4 axes of the tetraverse, which is the tetrahedral form standing on a triangular face. And then there's also, as we just pointed out, the XYZ that comes into the square faces. So this is just a model built. You put together these tetraoctatetras, which is essentially 6 triangular diamonds stuck together, cantilevered over each other. And it's the 60 degrees of these that creates the 90 degrees. Where have we got that? Anyway, so this is essentially the 64 tetrahedra. This is the form of the 64 tetrahedra. And what we show here is that it is essentially 2 intersecting 4 frequency tetrahedra. So just as Dave intersected the 2 frequency tetras to give you an octa in the center and 8 tetras on the outside, if I did that with a 4 frequency, I basically get this shape, which now has a cube octahedron on the inside, right? And this takes us back into the quantum realm. So we've established logically from the first slide of the collapsing cube that the edge length of a tetrahedron is the Planck distance. But everything radiates out in a sphere. So the radius here matters. The radius is actually your unit 1. So this radius of 1 has to be equal to the tetrahedral edge, the edge of the tetrahedron, and therefore this radius is obviously smaller than the Planck distance and would violate itself. So this object cannot exist in a 3-dimensional space. You have to find the object where the internal radius and the external edge length are the same, and that object is the cube octahedron. So here are the radial spokes, and you will see that every radial spoke is exactly equal to an edge, so that every one of these triangular faces is actually a tetrahedron point down sitting at the center of that cube octahedron, and there are 8 of these we show. Basically, this is the other way of looking at it. This is the tetrahedron at the top that time we pointed out. And what we're going to do is we're going to put a tetra into that triangular face. And if I do that 8 times, I basically make an entire structure that is fractal. As I expand from a single frequency to a double frequency, That happens with all 8 of these rays as it expands outwards. 8 triangles of the cube octahedron and 6 squares of the cube octahedron are completely balanced volumetrically, so that as the system expands, it maintains its form of 8 triangular faces and 6 squares. It doesn't matter how big or small you make it. Our point is you can't make it any smaller than the quantum Planck distance. You can make it as large as you want after that. So that is the
can I pause you there? Can I pause you there, Joe? And
yes.
I just want to bring it back one last time to Nassim Haramein's shape and show basically the one difference there. And that is here. So when Nassim Haramein goes to this shape here, basically he's saying that it's the 8 intersecting shapes, but really what we're saying is all he's created here is a 2 frequency cube octahedron. And if you go back inside of this, so this is 2 octaves, it's doubling for him, right? We don't really talk about octaves as much as we talk about the frequency. The thing about it is, what he's really done is he's created a 2 frequency cube octahedron, and that top triangle on the triangle on each side that's protruding, that is the top of a tetra octa tetra.
Right.
And that's basically it. So inside this 2 frequency cube octahedron, there's a 1 frequency cube octahedron, and that 1 frequency has a triangle pointing towards the center, an octahedron, and then this top tetrahedron again. And I think that's a really important thing, because what we're talking about there is, I think looking at that pattern is an over complication of looking and starting with, hey, here's the cube octahedron, and we have the tetra, octa, tetra coming out from every triangle, right? And that is the basis of this being the essential object in the universe, right? So you talked about the idea that if you looked at the single tetra coming off of this, like any side, if that was the central structure, then the radial length would violate the Planck because it's less than the center. Whereas this, you can see the red radial lengths, those are interchangeable. Those are interchangeable with the outside, right? I can put this here, and I can put this here. And what we have here is just to demonstrate, right? Just to demonstrate that this length here is the same as the outer length. The radial length,
which is the tetrahedral edge length that we have established, is the Planck distance.
Correct.
Right?
Correct.
So this object has a radius of the Planck distance and an edge length of the Planck distance. And the cube octahedron is the only form in universe that happens. One form, one structure where the radial length and the edge length are the same, which is why Buckminster Fuller called it vector equilibrium. All the vectors of energy are completely balanced. Nassim just calls it equilibrium. I think it means exactly the same thing. Nassim is showing is that this central single frequency cube octahedron will expand fractally to his shape, the 64 frequency, which is a 2 frequency cube octahedron. And that can continue on and on and on to the largest possible shape. And what you're maintaining is always this cube octahedral central core, which is the secret to the whole aspect of 64 tetrahedra. And what it means is, because we've taken it down to the quantum Planck realm, that this absolutely establishes the grid, the matrix. Nassim uses the term grid, but everybody understands what the matrix is. But remember the Matrix movie, and every time you saw the matrix being articulated, it was cubicles. All of the lines were cubes running, right? Whereas in the real grid, those cubical lines are intersecting with tetrahedral lines. The grid is actually tetrahedral, not cubical. Right. They coexist within each other because the intersecting tetrahedra actually outlines the 8 vertices of the cube. The cube is made out of intersecting tetrahedra themselves, because a natural cube will always collapse to a tetra, octa, tetra. A cube has to be a compound object because a primitive cube cannot exist on its own.
Great. So let's go back to your video quickly, and then let's do a construction of this.
Right. So we're showing here, as he says, starting from a cube octahedron on the inside, tetra, octa, tetra, gives you a 2-frequency cube octahedron on the outside, tetra, octa, tetra, a 4-frequency, and this just grows, maintaining that omnidirectional growth. One of the things we know from the cosmic microwave background, the CMB, many other ways of measuring what we call, is the universe flat? Right now, it is established that we live in a flat world, meaning Euclidean geometry applies over the large range of universe. When we get to densities like planets and stars that compress the space around it, in that local area, you're talking about Einsteinian geometry, which is non-Euclidean. But when we look at the entire universe over space and time, the entire universe is flat, right? And so what that means, that flatness is because the universe is expanding spherically without distortion. Because if it distorted anywhere, we would be able to see along a line of sight a distortion in the energy that's coming from a gravitational wave or from a light wave. And we do not see that. Starting from the cosmic microwave background radiation graphic all the way to where we are, Euclidean geometry, flat space geometry is what we use. Only when we get into densities that compress the space around it do we have to use Einsteinian, Minkowski, and other kinds of geometries to describe that space. So again, the flatness of space is established because the cube octahedron expands omnidirectionally without distortion.
Excellent.
Otherwise, that could not exist. So here's a tetra, octa, tetra that's built. And out of these...
So it's a bit hard to see, but what you're saying when you say it's built, you have basically a white, it's hard to see, but a white...
solid form of diamonds on the inside.
On the inside, yes.
Surrounded by the edge length of a Planck tetrahedral distance.
Yes.
So again, this is a quantum object. This whole object represents a quantum component. And here are just some ways to show how it is fractal. If I look at a 1-frequency tetra, octa, tetra, if I go to a 2-frequency, I get the same triangular shapes, but the internal complexity, the internal structure has become far more complex. Here's a 3-frequency as an example. Again, you maintain all of the triangular diamonds. Here's a 4-frequency with pieces taken out to show that at every level it's fractal. Here's the 1-frequency, here's the 2-frequency, here's the 3-frequency, and this is a 4-frequency tetra, octa, tetra, and it's completely fractal, which is why every ray of those 8 emanating rays fractally continues to expand without loss of external shape. Here. And this last diagram, again, is built, and this is just to show, to articulate. Here is the 1-frequency tetra, octa, tetra in white, and if I turn that into a 2-frequency, every one of these diamonds is now 2 frequencies, we find that the 2-frequency expands exactly in the same shape as the 1-frequency. And this is happening simultaneously across all 8 of those radiating rays. So the point here is that what we have is a model of a wave, not just a model of a structure. So when I make a wave, whether it's a sound wave or a light wave, that wave emanates, radiates omnidirectionally until it hits something and gets stopped, right? If I had a sound wave or something like the Big Bang, which is the ultimate wave, that Big Bang, the center of that crust, the universe has been expanding omnidirectionally. Now we're off on one direction only. All we can see is the radial distance of the universe. We can't see past that radial to the other radius on the other end. There's an entire part of the universe that we can never see, because as the light travels outwards, we get to a place where we can no longer see past the origin of that light. Right? So this is a fractal. This is a built fractal, and it shows tetra, octa, tetra, supported by cube octahedron. So essentially what we're showing is that we're talking about a 4-frequency tetrahedron base. So if we intersect this the same way that Nassim intersected his 2-frequency bases, we're building a larger cube octahedron in the center. And this is an example of how that tetra-octatetra that we've built comes out of a 4-frequency tetrahedron.
Yeah, and when you say that, what you have to realize is when you look at this cube octahedron, if
Yeah,
I could build a point on here and on the sides, and what I would have is actually a 1, so a 1, 2, 3, 4 frequency tetrahedron, right? The octahedron first shows up when I built the 2-frequency tetrahedron in green earlier. The first time a cube octahedron is when you build that 4 times, right?
right. So if
So
you
are we
intersect, you got a cube octahedron on the inside.
perfect? Yeah. Now, would you like it to do the construction now?
Yes, I think so. Let's move to that.
Okay. Okay. So here we have the cube octahedron, and we have 8 different triangles, and we're going to show the connection to each one of these triangles is like an upside down tetrahedron where the bottom point in the center comes out to here. From there, we add an octahedron, which I'll do in yellow. And so there's the octahedron. So now you have the tetrahedron in the bottom, octahedron, followed by tetrahedron.
So again, what you're doing is on every one of the tetrahedra that emanates from the cube octahedron from the center that ends in a triangular face on the surface of the cube octahedron is being extended by adding an octahedron. And on top of that octahedron, you put another tetrahedron, and that is the fractal form of each ray of the wave as it expands outwards omnidirectionally. And because we have shown that this is the minimal, the quantum object,
Yeah.
when we extend this out as large as it can go, it means that every form can be made. And so this is a Planck wave, which is the smallest possible frequency of a wave. And by doubling the octave, as Nassim calls it, every time you double the frequency, that's a complete octave. If you go from middle C in the piano and you double the frequency, you get a high C. So that's what it means by an octave. An octave of sound is the same as an octave of frequency. And if you start with this primary octave, the Planck octave of the wave, I can then fractally build any wave of energy, which means everything on the electromagnetic spectrum is reflected by a wave. Everything in the universe that exists vibrates, and this is the form of that vibration at its Planck distance at the quantum scale. So to tie it together, what Nassim Haramein calls an octave, we call a frequency. So if you start with the smallest octave or the smallest frequency and you double it, you get an octave. So if we go from a 1 frequency to a 2 frequency, that's an octave jump. Every doubling is an octave jump. Like in music, you have your middle C, you double the frequency of that, you get a high C, right?
Right.
So that's how frequencies work, that's how waves work. What we're showing is that the 64 tetrahedron of Nassim, that's so important to his cosmology, is also important to us in terms of the structure, because what it is made out of is the component of tetra-octatetra, which for us is the primary component object. You build universe out of tetra-octatetras based around a cube octahedron.
Yeah.
The cube octahedron, because it is the only form that can expand omnidirectionally without distortion, and is also completely balanced. The 8 triangular faces that radiate outwards, the rays that we're building, and the 6 open squares that are compressive or contractive are completely balanced. So when that object expands, it's expanding exactly in the same formation and volumetric inside. As it expands larger and larger, it just becomes a larger and larger sphere.
All right. So, any concluding thoughts?
Yes, 64 tetrahedra that Nassim Haramein has built, which represents to him something like the vacuum and the boundary of a black hole. So cosmologically and mathematically, he has associated this shape with his cosmology. We arrived at this shape out of using the basic logic of going back to what is a quantum distance. And once we established that a tetrahedron is the smallest quantum object, but because it violates itself, you have to go to the first cube octahedron, which gives the radial length and the edge length the same. Once you begin expanding the cube octahedron through the 8 triangular faces with tetra-octatetras, you end up essentially with the 64 tetrahedral form that has emanated from the quantum structure. Anything in the universe that can be built, any structure can be built using this construct. So he has associated the 64 tetrahedra as his central aspect. And what we are showing is that it is actually the grid, the matrix, that subsumes everything in the universe. And in the matrix, when we see all the cubical numbers falling like this, in reality, that should be converted into a tetrahedral aspect, the emanating 8 tetra-octatetras of the cube octahedron, and then you would have an actual grid that represents the physical grid of universe. The physical grid of universe are cube octahedra with octas and cube octahedra stacked. And the way you build that is by putting tetra-octatetras on a cube octahedron.
Excellent. And a great introduction to that is our video, We Live in a Tetraverse, which is very introductory, but goes through a lot of the same principles we shared today. Thanks so much, Joe.
Yeah. Thanks, Dave. Look forward to the next one.